Hello everyone. So in our previous video, we discussed about a simple hash table. We saw what hash table does, and we also saw that when we use hash function to store the key value pair in a hash table, there will come a situation when there will be a collision. So in this video, we will see that how we can resolve that collision using a collision resolution technique which we call as separate chaining. So in our previous video, we saw a simple hash table where we had this array of key value pair and of size as 10. Our hash function was key mod size, where we divided key by size, and whatever was the remainder, we used that remainder as an index to store these keys with its values in this array. So 5 mod 10 gave value as 5. So at the fifth index we stored 5, John. At the first index we stored 1, Tom. At the 0th index we stored 10, James, because when we do 10 mod 10 or when we divide 10 by 10 we get remainder as 0. On the 6th index we stored 26, Tina. On the 9th index we stored 99, Sana. And when we encountered a value as 105, so our hash function returned us a value as 5, because when we divide 105 by 10 we get 5 as the remainder. So when we went to 5th index, we saw that there is already a value stored 5, John at 5th index. So this resulted in a collision which we discussed in our previous video. Now in this video we will see that how we can resolve this collision using a strategy called as separate chaining. So friends, what we do in separate chaining is, in case if we encounter a collision, let's say when we try to store 105, on the 5th index we already found that value as 5, John. So what we do is, when this collision occurs, then at the 5th index we simply store both the values in a list. So that list is nothing but a simple linked list, where whenever we encounter a collision we simply add that element in that list which belongs to that particular index. So when we try to store many values which are huge in a small fixed size array, then there will be a situation where we encounter frequent collisions. So we simply add those elements into the list which belongs to that particular index. So when this list grows, it looks like a chain. So therefore, the resolution strategy is separate chaining, where with each index we create a separate chain or linked list to store the values which are getting collided. So let's see an example. So friends, in our previous videos, when we discussed about the linked list, we saw that how we can create a singly linked list, doubly linked list, and circular singly linked list. So if we take the example of singly linked list, we saw that there is a head from where basically the singly linked list starts, and each node basically points to the next node in the list, and the node which is at the end points to null. So here, instead of taking the array of key value pair, what we do is we take the array of hash nodes. So here if you see, let's say if you want to store 5, John, we first pass the key into the hash function. We get the index which is 5. So instead of directly storing at this index, we create a hash node. So this hash node is pretty much similar to the singly linked list node, where we had a data and a reference to the next node. So here we simply add one more value which is the key. So here our hash node has 3 attributes. One is the key, other is the value, and the third is the reference to the next hash node in this list or chain when some collision occurs. So this terminology you can simply take it as hash node. So in our upcoming videos we will discuss in greater detail what is hash node. Now let's say if we want to store 1, Tom, so at the first index, we store 1, Tom in a form of a hash node. At the 0th index, we'll store 10, James. And similarly, the other values. But when we encounter 105, Mary, so our hash function is returned a index as 5. So here when we go to index 5, we see that there is already a hash node available having key as 5, value as John. Now here we have encountered a collision. So what we do is, as this hash node can be treated and converted into a list or chain, what we do is we can use its next reference and we can simply store 105 as key, value as Mary, and its next is pointing to null. So here whenever we encounter a collision, we keep on adding those elements in this chain, which we also say that it's a form of a linked list. So by separate chaining technique, we can resolve these collisions and we can store the values in the form of a linked list when any collision occurs. So we'll see the importance of this hash node and this linked list in our upcoming videos when we will implement a hash table using the separate chaining technique. So friends, I hope you find this information useful, and in case if this information is useful to you, then please like this video. And if you are new to my channel, then please subscribe to my channel so that you never miss any update. Thanks, have a nice day.